a chunk of world-first technology, a tanker of liquid nitrogen, and a team of nervous engineers. With a prestigious project and years of work behind them, the test they're about to do needs to succeed. It's revolutionary, pushing the boundaries of innovation. Destined for fields previously thought too challenging, a gas plant is being shrunk to a quarter size and carefully squeezed onto a floating hull. At 1/2 kilometre long, Prelude is one of the largest structures that man has ever sent to sea. Prelude is designed to cool gas to a chilling -162 degrees Celsius. This shrinks it and turns it into liquefied natural gas, or LNG. The challenge is in transferring this volatile liquid from Prelude onto a carrier, while both bob up and down on the surface of the ocean.
The carrier and the facility are actually moored together, and during this offloading process they'll be moving, and probably moving in different directions. Ideally, we would actually offload around every 5 or 6 days, and we've had to make sure that we can do this safely.
Technology for transferring fuel between planes has been in use since World War II, but technology that can speedily transfer vast quantities of liquid gas between vessels at sea has had to be perfected. That next level of innovation is being created in France. For the Prelude project to be viable, this marine loading arm has to work. Cris Moreno is here to test it for the first time.
There it is. That's the first marine loading arm. That is just incredible. That is absolutely, that's sublime. That's amazing.
Chris's excitement is understandable when you consider it's taken 50,000 man-hours to get to this stage.
The reason why I would almost love these loading arms is they're a first of a kind. You can imagine grabbing something that no one's ever played with, and then that gives you a sense of enjoyment, fulfillment, and it's also scary at the same time. You know, you don't really want to take something brand new and break it.
This enormous arm should be able to swivel, rotate, and follow the motion of an LNG carrier for the 15 hours it'll take to offload.
It's a brand new arm, so it's important that we see the system work spot on first time.
A dynamic test bench mimics the movement of the carrier. The arm should automatically pull itself into place. The team watches anxiously. It's a textbook connection.
It's just incredible, huh? The dynamics.
But then something unexpected occurs.
That wasn't meant to happen.
The loading arm has retracted too far and collided with itself. The engineers check for damage.
The good news is that none of the equipment was damaged during the test.
Despite the hiccup, the test is a resounding success. And with a plan in place to make sure it can't happen again, they move on to the ultimate test. Prelude's liquefied natural gas will be stored in colossal tanks deep inside the hull at -162 degrees Celsius. The team in France needs to prove the arm can perform in the extreme cold.
It is effectively the first time we're running the Prelude LNG loading arm at cryogenic conditions. Yeah, it is exciting.
They fill the arm with liquid nitrogen. It's cold, but not flammable like liquefied natural gas.
Once we achieve the low temperatures that we need, we will complete what we refer to as an emergency disconnection. And that's critical for ensuring the facility remains safe in case of emergency.
The test bench will simulate extreme sea conditions. Once the movement exceeds safe limits, valves inside the arm should close, allowing it to break away from the carrier. In this simulated emergency, only the liquid between the two valves should escape.
If the valves didn't function, we would see continuous liquid nitrogen being spilled into the ground. So there is a very, very strong requirement here to demonstrate that we do not have that occurring. Good result. Very happy.
The marine loading arm has functioned perfectly. It'll now be dismantled and shipped to Korea. Once 6 more are built and tested, Prelude will be able to offload liquid cargo at sea.